Alright, in section 7.5 today, we're going to learn one more way to solve a system of linear equations. This one's using algebra as well, but this time we're going to just learn a different method of doing things. Yes, we're still going to have to eliminate a variable, but I'll show you an alternate way instead of substitution. Before I do that though, I want to just review two basic properties of linear systems that we actually need to know before we can actually solve by elimination. So remember in section 7.2 when we asked you to solve graphically? So yeah, let's just do this again as a review. Okay, really quickly now. Let's take our first equation here. Y equals to negative 2x plus 8. We're going to try to graph this out. So I'll use that slope-intercept idea. So the slope in this case is negative 2 or negative 2 over 1. That just means you go, what, down 2 for every 1 unit you go to the right. We've also got a y-intercept of 8, so with that information I should be able to plot the point 8, go down 2, right 1, go down 2, right 1, 2, right 1, 2, right 1. Connect the dots together with a straight line, and there's my graph of the first equation. How about the second one, x plus y equals 6? I'm going to this time use the table of values just to spice things up. If I let x equals to 0, that means y equals 6. If I let y equals to 0, I think x equals to 6. We'll plot those 2 points. We'll connect them together with a line. And then where's my solution again? You bet. Where the two lines intersect. And it looks like the coordinates 2, 4. So, the intersection point is my solution, 2, 4. Cool. That's what we did in 7.2. Now, here's the interesting stuff. Let's do investigation number 1. Let's see what happens if we actually multiply both sides of the first equation by the value of 2. So remember our first equation was y equals to negative 2x plus 8. Now I'm going to ask you to multiply everything by 2. So let's make this 2y negative 4x. Whoa, what happened there? Get rid of it. 4x, and this becomes plus 16. If I ask you to graph this out really quickly right now, I'll make a quick table of values when x is 0. That means I have now 2y equals to 16. I guess y is 8. If I make y 0, that means negative 4x plus 16 equals to 0. X must be, I believe, 4. We'll graph this out, and you'll notice that this is a nice slanted line. Whee! Then it says we're going to actually do the same thing to the second equation, but this time multiply it by 3. So our second equation is x plus y equals to 6. Multiply everything by 3, so 3x, 3y, 3 times 6. That's of course just 18. Graph that out. X is 0, y is 6. When y is 0, x is 6. Same thing, graph. Notice, I think you're like, hey, didn't we just do all this? And you're like, uh-huh. And you'll see that the answer, whoops, that wasn't a very good line. Let's try again. You'll see that the same answer appears. Yes, 2, 4. So what do you notice when you've multiplied both sides of either equation by a constant? Well, the key thing here is this. The solution stays the same. Cool. So there's the result for equation or investigation number 1. Let's turn the page now. And let's see what happens with investigation number 2. Same two equations, remember. Recall the solution once again is 2, 4. Now let's move all the variables to one side, and let's see what happens if we now add the two equations. So in this case, I'm going to move the negative 2x to the left side, so I get 2x plus y equals to 8. X plus y, 16 is still the same. Or it's not 16, 6. And in this case, I said let's add the equations, so I'm going to add them all up. And we'll have 3x plus 2y equals to 14. Nice. Let's graph this out as well. I'll make a quick table of values. You do the same. When x is 0, y is 7. I'll choose x for 2. I get 3 times 2 is 6, so 6 plus 2y equals to 14. Subtract 6 off of both sides. I think you get 4. That's good. I'll plot the 2 points. Draw the line. Whee! And you're like, okay, I've got one line, but I don't have the solution or intersection point. Not to worry, I want you to do the same thing by now subtracting those two equations. So the same two equations from above. I'll say 2x plus y equals to 8. X plus y equals to 6. This time, let's subtract. 2x minus x is x. The y, take away y, is gone. X equals to 2. Well, that's just a nice vertical line at x equals to 2. And lo and behold, what do you notice about the intersection point? Yes, you're right. It's the same. Also 2, 4. So property number 2 says when you add or subtract equations of a linear system, guess what? The solution is the same. Cool. So it's these two properties that's going to help us now deal with solving linear systems by this method called elimination. So you're going to be looking to either add or subtract the equations to get rid of a variable. So in example 1a, notice that the coefficients for the y's are both 3 and 3. I know the signs are different, but at least the number, the magnitude is the same. So now you should be able to either add or subtract to get rid of the y's. Since one is negative, one is positive, to get rid of it, I think we're going to have to add it. So when we add, we get 4x plus 2x, that's just 6x. Notice the negative 3y plus positive 3y gives us 0y. We don't need to write that down. And 6 plus 12, of course, is 18. Divide both sides by 6, and you get x equals to 3. Yay! Don't forget you're solving the system, so you need to find out the actual y value. So go ahead and plug it back into either one of the equations. I happen to choose the first one, so 4 times 3 minus 3y equals to 6. 4 times 3 is 12. 6 minus 12 is just negative, what? Negative 6. So y equals to 2. And there you have it. Our solution then is 3, 2. Done. Alright, looking at part B now, you're going to have to do the same thing. Either eliminate the x or the y. It's up to you what you want to choose. But notice in this case, I'm thinking, you can decide to eliminate x or y. But wait a minute, the coefficients aren't the same. So what you need to do first is actually make the coefficients the same. So, do you want to eliminate x or do you want to eliminate y? For my purposes, I'll try to eliminate y, which means I need to have the coefficients in front of the y being the same. 1 is 2, 1 is 4. I want them to be the same. So you probably want to find the lowest common multiple of 2 and 4. Which means I think you got to take equation number 1 and multiply that by 2. So 2x minus 4y equals 14. I'll copy equation number 2 down. No change required there. Plus 4y equals to 1. Notice now we have the same situation as example 1a. So up to you, add or subtract. 2x plus 3x is 5x. Then negative 4y plus 4y is 0y. 14 plus 1 is 15. Very easy to solve now. X equals to 3. And once again, plug it back in to solve for y. Up to you which one you want to plug it into. Excuse me. I'll plug it back into the first one. 3 minus 2y equals to 7. Just need to subtract 3 off of both sides. Negative 2y equals to 4. And y equals to negative 2. So our solution in this case is 3, negative 2. Alright? Okay, you turn the page for some more practice on your own. Okay, try example number 2, A and B. Okay, and you try on your own, so pause the video. When you're done, come back, check your answer with mine. And by the way, you can eliminate X or Y. It's up to you. Enjoy! I choose to eliminate, let's eliminate X this time for fun. Common multiple of 3 and 2 is 6, so first equation I'm going to times it by 2. Second equation, I guess I'm going to times that by 3. In this case now, since the coefficients are the same for x, I'm going to subtract 4 minus 9 is negative 5y. I should have said 39. So 24 minus 39 is just, I think, negative 15. So y equals to positive 3. And plugging it back into either equation 1 or 2, doesn't matter. 3x plus 2 times 3 equals to 12. That's 6. 3x equals to 6. X equals to 2. If you got the answer 2, 3, congratulate yourself. Give yourself a pat on the back. That's the answer. Okay. Do the same thing for B. This time I'm going to switch it up and try to eliminate y. So I'll take equation number 1 and I'll multiply that by 2. 4x minus 6y equals to 20. The second equation I just keep as is. No need to change. I'll decide to, I guess in this case, add the equations and look what happens. 4x plus negative 4x, that's 0x. Negative 6y plus 6y, that's 0y. So the whole thing on the left side is 0. And then 20 plus negative 20 is also 0. Huh. 0 equals to 0. True statement or false statement? True. So what does this mean? This means that the two lines must be, think back to that chapter when we graphed the lines. These two lines must be, the same. So the two lines must be the same. So, therefore, you say there are infinite many solutions. Okay, so when 0 equals 0, true statement, infinite. By the way, if, for example, you had some sort of statement like 0 equals to 5, is that true or false? Yeah, in that case, that's false. So what do you have there? What type of lines do you have? In this case, yes, the statement is false. And you don't have the same lines, but you have probably two parallel lines. So think back to that section 7.2. And in this case, not infinite solutions, but no solution. Okay. Alright, so try example 3 now. 3 requires you to solve these systems once again by using elimination, but wait, they're not in that nice standard form where we have all the letters on the left side and numbers on the right hand side. So guess what you need to do first? You need to rewrite them in in standard form. So for A, to do that, you probably have to do some expansion and rearranging. For part B, you're going to have to clear the denominators. What to do? Well, if you want to try it on your own, please do it. You don't need me. Stop the video, come back, check the answer. For those of you who would like to do it with me, then follow along and we'll try to solve 3A at least together. Okay, the goal is to have both the x and y's on one side. So, taking this equation, I'll rearrange it with 2x on the front. Y minus 4y is minus 3y equals 10. Taking the second equation, going to expand, and by the way, that's just 4x plus 4y. So 4x, 4y plus y must be 5y equals to 42. Alright, once again, the variable or the coefficients are not the same. You have to decide what you want to do. I will multiply the first one by 2 to make it 4x, 6y, 20. Keep the second equation as is. X plus 5y equals 42. Now you have to add or subtract. I probably think we should subtract, since the 4x has both 4x on top and bottom. Wow, so slow. 4x minus 4x is gone. Negative 6y minus 5y. Negative 11y. 20 minus 42, that's negative 22. So solve for y, we'll divide both sides by negative 11. Y equals to 2. Cool. Go ahead now, you go back and solve for x. Up to you which equation you want to put it into. I'll put it back in this one. I think it's the easiest of them all. So 2x minus 3 times 2. Wow, 3 times 2 equals to 10. That's 6 plus 10, that's 16. So 2x equals to 16. So x must equal to 8. So the solution is 8, 2. Ta-da! Alright, you try part B. You're going to have to try to clear the fractions. Probably want to multiply the terms by the common denominator. In this case, I think the first one, the common denominator is 10. So if we multiply everything by 10, x over 5 times 10, that's just like 10 x over 5. And that simplifies to 2x. So think about it, that becomes 2x. plus 3y. 2 times 10, remember all the terms, not just the ones with fractions, 20. Same thing with the next one. I think we multiply that by 10 as well, so that's 5x plus, I think, 4y equals to 29. There you have it, 2 standard form equations. Go ahead and solve, okay? I'll let you try this as an exercise. You do it, you get the answer, come back and check it out. By the way, you need to show your work. Don't just copy my answer 1,6. I'll be checking to make sure you showed your work. Haha. Okay, so that's pretty much it for the idea. So let's just try to use the same ideas to solve 2 word problems, and then we'll call it a day. Example number 4. So, create the system of equations, then go ahead and solve. So, scientists worked for 6 days on a project. Her assistant worked for 5 days, earning a total of $780 together. That's cool. But they earned $500 together on their next project, which required them 4 days of work from the scientist and 3 days of work from the assistant. So the question is, how much did each earn per day? Once again, when I solve these questions, I like to identify my variables, and let me tell you that you can use boring x and y, or something else. It's up to you. I'll call x the amount earned. By the scientists. Y can also be the amount earned by the assistant. And now you're ready to set up the equation. 6 days and 5 days, so 6 x would be the amount earned by the scientist on 6 days. 5y would be the amount earned by the assistant. Wow, lagging. $780. Next part, 4 days, scientists, so I guess 4x. 3 days from the assistant, 3y. That must equal to 500. There's your system. Go ahead and solve and see how much money you get. Okay, I'll solve this by elimination. Probably want to find, I don't know, it's up to you. Make the x's the same coefficient as the y's. I think I'll use the x's this time. 6 and 4, the common multiple there would probably be 12. So 6 times 2 gives you 12, right? So 12x times 2, 5 times 2 is 10, times 2, what's 780 times 2? Ooh, big number. 1,500 something, 1,560 I believe. Okay. Take that second equation, gets multiplied by 3, so 12x, 9y, 1,500. Now I'm ready to add or subtract. In this case, to get rid of the x, I'll subtract. So y just equals to 60. Oh, 60 bucks. Nice. You guys have always told me it's nice to have nice numbers. Okay, well here you go, nice number. Now go ahead and solve for x. So we'll solve for x. Up to you which equation you want to use. I'll use the first one, 6x. 6x plus 5 times 60 equals to 780. 6x 300, so that's 480. X must be 80 bucks. So, scientist earns 80 while the assistant makes 60. So I'll write it down in a sentence. The scientist earns 80 per day, and the assistant earns 60 per day. Okay? Alright, well, you try part B, okay? You read it, see if you set the equations. Once you set the equations, double check back to make sure the equations are right with mine. Then go ahead and solve using elimination, please. Go for it. Regular hours, 4 overtime hours, 166.40. Next week, 27.5 hours. So let's gain 20 regular hours. 7.5 overtime hours, $200. Alright, go ahead and solve. You decide it. You do it. This one's not that hard. Y equals to 960. X, I believe, just equals to 640. Not very good in terms of the wages, but nonetheless, hey, she's getting paid to do some work. Alright, we're done.